All right, solve and graph the solution. And now this time we've got an absolute value inside of a compound inequality. So I think, yeah, these ones can be um, pretty interesting. So first off, if we'll do it just if it's positive, if x plus 6 or x minus 6 is positive, and then we'll do it if it's negative. So if it's positive, then everything just works out how it is. So we'll have 2 is less than or equal to x minus 6, which is less than or equal to 5. Add 6 to all sides, and we get 8 is less than or equal to x, which is less than or equal to 11. And so if we were to make a number line, we could graph that out. We'd end up with 0, negative numbers, positive numbers, and we'll start with here's 8, here's 11, and we're looking for all the numbers in between those two. So solid circle at 8, solid circle at 11, and shading in between those two. All right, that's if the quantity x minus 6 is positive. If, however, that quantity is negative, then we're going to end up with negative 2 is greater than or equal to x minus 6, which is greater than or equal to negative 5. Here again, we would add 6 to each side, and we'll get 4 to all three parts, not just each side, all three parts. X is greater than 4 is greater than or equal to x, which is greater than or equal to 1. And you might want to rewrite this with your lowest term first. So 1 is less than or equal to x, which is less than or equal to 4. That might be a little bit easier to graph. But either way, we're looking for the numbers in between 1 and 4. And again, both inclusive, just like with 8 and 11, so because there's the or equal. So in our compound inequality with absolute values, we ended up kind of with two different and situations there together at the same time. All right, let's go for this other one over here. And we've got 0 is less than x plus 3, the absolute value of x plus 3, which is less than 1. So if if x plus 3 is positive, then 0 is less than x plus 3, which is less than 1. Subtract 3, and we get negative 3 is less than x, which is less than negative 2. Graph that out. And let's get that a little bit higher up. All right, so again, 0 and negative numbers, positive numbers we're looking for, negative 2 and negative 3. My scale is obviously off here, but we've got open, open, numbers in between, negative 2. Negative 2 is, oh, I'm sorry, it was written the right way. Negative 3 and negative 2, and x is in between those two. So here's the first solution set. Next we have, what if x is negative? And so we'll have negative 0, which is just 0. So 0 is greater than x plus 3, which is greater than negative 1. Subtract 3 from all sides, and we get negative 3, which is greater than x, which is greater than negative 4. All right, and again, we'll go to, let's see, so negative 4 is less than x, and that's less than negative 3. And so here we've got open circle at 4, or negative 4, and shading over to 3. Now notice what's going on here. So all the numbers between negative 4 and negative 3, not including negative 4 and negative 3, are solutions. And then again from negative 3 to negative 2. So negative 3 is not a solution. Don't let it trick you that since it's part of this that it's included. It's not. In the first one, it is not a solution. It is excluded. And in the second one also, it is excluded. So negative 3 is not a solution here. But here, there you go. So hope that helped.